This video is sponsored by Autodesk. So today we're going to look at a compound I've put together called Ignite, and then it's going to start off really simple and then we're going to get a bit deeper. So let me just show you Ignite really quickly. Here's a sphere. I'm just going to scale that down ever so slightly, and we'll just drag that into the viewport. I'm going to type Ignite and I'm just going to plug the sphere into there and that out to there, and let's just have a quick look at the resolution for this. I'm just going to bring that up to like 2 for a minute. Rewind and play, and we have combustion. So that is now, if you use this or make your own, that is how quickly you can create combustion. No messing around, literally just plug your shape in and we're away, and it's all very quick. Inside Ignite, I'll just maximize this slightly. Inside Ignite there are like a few things. I've tried to just kind of keep some defaults so that combustion just works straight off the bat. You know, usual stuff, start and end frame, everything starts with relative, so you know, we haven't got like crazy detail straight away. All your temperature settings are in there. Then we've got 3 fuel attributes. 2 of them will be switched on in the beginning, set to butane and propane. We've got sulfur settings, obviously combustion settings. I've added a volume material in there as well, so that you could just tweak the look straight away. And then something called turbulence vorticity, which is basically turbulence mixed with vorticity node, but it actually gives some interest into the combustion straight away, even when it's just on something as standard as a sphere with not many divisions in it. So that's Ignite, and it should make things a lot quicker for you to ignite stuff. So we're just going to pause this graph for a minute. Now we're going to get into something ever so slightly more complicated, which I'm going to simplify for you guys so that you could just use it. But I kind of want to show you how I've made it, where I'm going with it, and yeah, what the progression's going to be. So let's just put that sphere on a display layer. You can't see my channel box, it's off screen, but you don't need to see it. So let's unhide. Well, let's just unpause this graph for a second. Okay, so here we have a sofa. You can have this sofa. I modelled it some time ago for something, I don't remember what, but if you need a sofa, it's yours. So here we're using Ignite again, and we've got, you know, a whole load of stuff going on here. And basically in this example, we've got ignition from some color values that are happening over our sofa. So we've got very quick ignition from values that we've added to this, so that rather than just adding, you know, fire straight over the top of it, we can kind of control it a little bit and get it to start burning in different areas. So I did this in a couple of different ways, and we can tweak it. Let me just get a graph back in a minute, and we'll just unplug Ignite for a second. So the first thing I did was hack this. If you just go into Windows, Bifrost browser, in fields is boiling noise example. And I knew that within boiling noise, it created this kind of displacement through fields, but I knew that it must create it through color. So I went into boiling noise and hacked apart certain aspects that I needed, which is this down here. I've just undone some things that I don't need, but it's basically a fractal noise field going into an F-curve field, and then we've got a translate field. Some of this I've pulled apart because I'm not using it. This is just based on time, some of this stuff, and animation, which we can hook back up. Then we've got a translate field, which I've adjusted. I've just put in a vector value there so that we can move it, and an F-curve field. I've stuck that in as well, just so we can control the intensity of the colour, and it just goes into, you can see it's still called witch's brew material. and we're using that, which is basically just this. So we've got a vector field, and it's going into this create material compound. All of this created by someone in the Bifrost team, maybe Jonah, I believe. Possibly not. So from here on out, I took that material, and I realised that somewhere within this there was a in create material, there was a set geo property called point color, and that caught my eye. So I just made sure that I created a get geo point color. I don't need this vector 4 anymore. And just plumb that into vector 3 to scalar, and then anything greater than, I have to thanks Stefan for this, actually. Stefan in the Bifrost Discord. I had it like almost there, but it was just like this and that I was missing, but thanks for that, Stefan. Greater than allows us to look for colour that is greater than a certain value, and then we find all true in array, and we get from array construct points, set point shape, which is what we can see here. We're putting points over the top of where those colour values are, and then from that set point shape I'm using that to ignite. You can do anything once you've got that. Once you get to this point, we can do anything. You can run a particle system for it from it if you want. If I just type we'll just put in spark, and we can just hook those points into there and bring those particles out, and should be able to rewind and play and have particles coming out of there. It's sort of happening. I don't really know what's I don't want to get into making that work, but you get the point. So yeah, Ignite works over by using these points and all of this information, which I will tidy up, compound up, and either add to Ignite or just create a node, a compound on its own. But what's nice about it is that we've got these translate field attributes. So if we wanted to, we could create a kind of ramp. I don't believe there are any gradient ramps in Bifrost yet. It would be really nice if we could have some kind of like almost layered gradient ramp that I could layer over the top, that we could layer over the top of these colours, and then just sort of animate it up and down. I haven't been able to find it yet. Okay, so but what we can do, we can get like fairly close-ish. We could animate the value in X, and if we make that fractal kind of bigger, so keep the frequencies down, take the frequency, down as well, and the ratio, let's just kind of do that, and then if we just sort of move that along, see, we could animate that along there over time, and it would potentially do its thing. So I mean, why not? Let's just do it. Let's just lay down an input. We could do this with time, and we could do this with time. Let's just do it with time. Obviously, you can hook it back into Maya. If we put an input in there, put that into an input, we could then animate it within Maya. But we could also do it with a time node. And let's just lay down a divide node, because I'm going to need that. With a value, I'm going to need that as well. So we just get our time into divide and that into there as well, and then we can plug that into X. Come on, get in there. Plug that into X, and potentially that will animate over time. Oh, I haven't got a value in here. Let's just put a 1 in, rewind, and there we go. So we've got it procedurally animating over time, which is possibly nicer anyway. I guess it's nicer because we could just keep everything in here and still play around with certain attributes, but you might want to take it and animate it in a different way back into Maya. If you don't know how to do that, I'll just quickly show you. We could take this X attribute if we want, and we could stick it into an input like so, And then when we select the Bifrost graph shape in the outliner, we can see that we've got X here, and we will be able to middle mouse drag that backwards and forwards, right click and add a keyframe. But let's just remove that for now. Once you remove something, it's still going to show up on the input. We're just going to delete that port. So that's animating it over time. And we can see that these points are also following that. There are so many ways to do something in Bifrost. We could have done this with like a culling points, and we could have used like a cube as a bounding box to animate over the top of that. But I think this is probably the best way for now. So that will just plug straight back into Ignite, and if I just plug Ignite in here and press play, let's just bring the resolution from absolute to relative for a minute so that we can just see what's going on. Obviously it's going to look awful, but we'll just stick a 1 in here and then pull back, and I'll do a little play blast just so we can see what it looks like animating over time, and we will come back to the video. So we can see it's obviously following those points, it's burning along. We could probably add some kind of iterate node so that for every point generated it just continues adding a point afterwards. That's probably a good idea, and I will work on that. But for now we can see that we can actually get a combustion source moving. So obviously that's super low res, but I didn't want to spend too much time simulating at a really high resolution, just because we've got a lot to get through. So I will compound all of this up, and when you download the scene, it will make sense how to use it all. So that's one version. As with anything in Bifrost, there's multiple ways to do the same thing. So we could actually just do, we could go scatter points, and we could add a fractal into the density weights. So just type fractal noise into here, and then we could get the point position from this. Plug that into the position, plug this into scatter, and if we plugged points into here, we should just be able to see those turn up, and then we could just use those points inside of Ignite to generate the combustion. And then obviously we can just sort of scale down the amount of points that we've got. And we could do a similar thing with the time on the fractal noise itself, just by adding the time node. And we can multiply that with various other values. So it's just another way of doing it. Obviously this way we're not going to be using our own painted version. But I'll leave this in the file as well, so that you can play with different ways of setting fire to things. So this is a plane, which is fairly self-explanatory, I think. And if we go into Mesh Display and open up the color set editor, we can see that I've created a color set. Again, you should know how to do this, but if you don't know how to do this, just go New, Color Set. And then we're going to paint a color set, so we just double click on here, we'll flood that black and then turn it to white, and then we'll just, you know, do something silly. So for me, I'm calling this color set, I'm calling it Burn, and Burn is going to be useful for us because we're going to be able to tell certain aspects to use the Burn attribute, which is a color set for something. So in here it's all going to look a bit mad, but I will tidy all of this up and again create compounds so that you can use it more easily. So in here I'm using a getGeo node, and its property is Burn, so it's going to pick up the RGBA property from the color vertex called burn. None of this is working because it's not actually plugged in. Let's just plug that in down there. So basically, all we're really doing is just add a watch point, and we should be able to see the burn is in there. So burn is one of our properties, and we're basically just taking the color and pushing that into the tearing and the tearing weight threshold of an NPM cloth. So what that means is we can tear cloth in certain areas, which is nice. We could use that on its own, but we could also then come out the back of the NPM cloth after post simulation. And again, Stefan helped me with this greater than and find all true and array. I was stuck there. So basically, we're looking for burn again post sim, and so we're looking for those color values that are being simulated. And then basically we're just constructing points on it, very similar to the sofa example, and feeding that into Ignite as well. But this time we're going to get some disintegration happening, hopefully, on this object. So if I rewind, I believe I need to switch off this object here, and NPM's not showing up because I haven't got that plugged in as well. So let me just plug in the NPM shape as well. And if we can see that the ignition is working in our face shape there, and if I press play, it's actually braking in that face shape as well. But what's cool about it is that because it's post sim and the ignition is looking for those points, it's going to follow them even after they're simulated. So we can see that these guys that are falling to the floor here, they've still got combustion on them, which now makes this kind of like a, if we could get it to look better, quite a good, quite a powerful feature. So again, I will upload this for you guys. With the scene file, you're going to get the Ignite node and all of these little experiments I've done. I will put things into neat compounds, maybe in a separate graph, but maybe in another graph you can have a look at the mess that I've been working in and see how it all works, because I think that's just as important. But we kind of get in there in terms of now being able to do things more easily in terms of, we've got an Ignite node. We don't have to go through and create a whole combustion graph anymore. We can say, no, let's spend our time on creating something more technical, and then all we need to do is actually just plug in the combustion, and it works straight away. So my next step is, wish me luck on this, my next step is going to be kind of reverse engineering this so that Ignite itself and the temperature of Ignite, of that combustion, is what actually creates the tearing of the NPM cloth itself. Which should be fun. It might not be too hard, but we'll see. So yeah, that's Ignite. Ignite is cool on its own anyway. Literally just plug anything into it. Ignite works with Spark, so we can just type mg Spark. So from the other lesson we've got mg Spark, we've got Dust, which is just our smoke kind of solver, and then we've got Ignite, and you could use the particle simulations from Spark to drive ignition, or you could do all three together. And in terms of creating those kind of ground impacts that we did in the previous lesson, we can now, so let's say we've got Spark plugged into Dust, and Dust is what's creating those smoke trails. We can now plug the particles also into Ignite, and we can start to use those separately so that we get some of those hot fragments coming off of that destruction, and or instead of that we could duplicate Spark and have less particles, and use that so they're not on every single one. But I'll do a separate tutorial for that, putting all these three guys together and creating something amazing. But for now, I just want to show you something slightly more complicated and kind of interesting, because it means we're moving towards being able to destroy things with other things, and it's not all just NPM. We're using colours, which are basically values, to and that's the interesting thing. Once you realise that colours are values, and those values can be turned into points, then we start to open up other areas that are more interesting, and that's kind of where I'm at the moment. So, hope you enjoyed it. Feel free to leave any comments. Obviously, subscribe and add some notifications if you want to see more tutorials from me. There's a lot more coming, and yeah, I'll speak to you guys soon. Thanks a lot.